We're going to continue with 7.1 worksheet. We will pick up number 6, bottom of the first page. I think the first video, the audio got inadvertently cut out after number 5. So number 6 here, we have y squared is equal to x and x equals 4. X equals 4 is a vertical line through the x-intercept 4. Y squared equals x. Y is positive and y is squared. We know this is a parabola that opens either to the left or to the right, and positive y squared would mean the graph's going to open to the right. Also, we can think of it as y. This is plus or minus square root of x. So here's square root of x, here's negative square root of x. And the way that these two graphs are related to one another, we see that the x equals 4 is always to the right of the x equals y squared in the shaded region. So we can think of this as a right minus left. We have to find our bounds. Our bounds, we can set the two equations equal to each other, set the 4 equal to the y squared. So we get plus or minus 2. So negative 2 is a lower bound, positive 2 is the upper bound. So from negative 2 to 2, our right graph is 4. Our left curve is y squared, so 4 minus y squared is our integral. And then once we find the antiderivative going through a power rule, we can plug in upper and lower bound. And once we have that, we have 32 over 3 square units. Number 7, we have x equals 3y minus y squared. Notice that the y, we know is y squared, so this is going to be a parabola that opens sideways. But a negative y squared indicates that this is going to open to the left. So we know the graph's going to open to the left. X plus y equals 3. That's a linear graph. Same thing as y is equal to x minus 3. So, sorry, y is equal to 3 minus x. So y-intercept of 3 and slope of negative 1. So from here, we can see that we have shaded region that is between the two curves here. So the way we find those bounds, we can set the two equations equal to each other. So 3y minus y squared, we set equal to 3 minus y. We have to go through factoring. We bring everything over to one side. Go through factoring, y minus 3 and y minus 1. So y is 1 and 3. So between 1 and 3, we have a right curve and left curve. Now, without a calculator, it may be kind of difficult to initially to know which one is the right and which one is the left graph. One thing we can do is we know our bounds are between 1 and 3. So if we just pick a value between 1 and 3, in this case 2, this is an easy value to plug in, we can plug 2 into both equations and see which one produces the larger value. The larger value would mean that at that point, the curve is further to the right than the other graph. So for instance, if I plug in 2 into the first curve, 2 times 3 is 6. 6 minus 2 squared is going to be 6 minus 4, which is 2. So this graph gives me a y value of 2. If I plug 2 into this expression, 3 minus 2, right? 3 minus 2 is going to be 1. So we know that 2 is a larger y value. A larger x value. Sorry, this is we're trying to see which one is further to the right. So 2 is further to the right than 1. So we know the 3 minus y squared will be the right graph, and the left graph will be the 3 minus y. We can go through, clean this up by distributing, combine like terms. Once we combine like terms, then we can go through power rule. Go through power rule to find the antiderivative. After we do that, plug in upper and lower bounds, and we get area of 4/3 square units. Okay, let's look at the back page here. Number 8, we have y is equal to x to the 4th minus x squared, and y equals 2x squared. First thing we do, we find the intersection. We can set the two equations equal to each other. X to the 4th minus 2x squared equals 2x squared. Bring everything to one side. Factor out the x squared. We get x equals 0, 2, and negative 2. So if we sketch the graph here, we have y equals 2x squared. We also have y to the x to the 4th minus 2x squared. If we sketch the graph, we see that there are two shaded region, and once we find those two shaded regions, we can set up the integral from -2 to 0 and then from 0 to 2. However, the y equals 2x squared is always going to be above the shaded above the other curve, since this x to the fourth minus 2x squared is never going to act as the top curve. So we could actually think of this as -2 to 2 and bypass the 0, since there's no change in top and bottom curve at 0, even though the two graphs intersect. And then the top curve is always the 2x squared, the parabola. And the bottom curve is always the x to the fourth minus 2x squared. But this will not be incorrect if you decided to set this up as two separate integrals from -2 to 0 and then from 0 to 2. Either way, we're going to get the same answer. Once we combine like terms, we'll go through power rule, plug in upper and lower bound. Make sure you always go through antiderivative before you deal with upper and lower bounds. So power rule, plug in upper and lower bounds, combine like terms. 128/3. Okay, number 9. We have y equals x. That's the linear graph here. We have y equals 1/x squared. First thing we do, find the intersection. Set the two equations to equal to each other. So x is equal to 1/x squared. The intersection is going to be at 1. Once we cross multiply, solve for x equals 1. So we can split this up into two separate integrals. First integral is a linear graph minus the x-axis. The second integral, the top curve, is going to be the 1/x squared. The bottom curve is going to be the x-axis. So from 0 to 1 is our first integral. From 1 to 2 is our second integral. And now, top curve is the x, bottom curve is 0. For the second integral, top curve is 1/x squared. The bottom curve is 0. Combine like terms, go through power rule, then plug in upper and lower bounds. Here, we can bring the x up to the top. X to -2, we can go through power rule. So that becomes x to -1 over -1, plug in upper and lower bound. Combine like terms, we get 1/2 minus 1/2, which is 0, plus 1, which is 1. Hey, number 10, we have 4x is equal to y squared minus 4. Notice that this is going to be, if we solve for x, this is going to be 1/4 y squared minus 1. So y is the one that's squared. This is a parabola that's going to open sideways. Positive y squared means the graph is going to open to the right. So we have 1/4 of y squared minus 1. Actually, this is slightly incorrect here. 1/4 y squared minus 1. The graph should extend past the x-axis here, past the y-axis. Okay, so this the vertex should be at -1 here. Okay, all right, and then we also have the linear graph, which is 4x equals y plus 16. So we solve for solve for x, we get 1/4 y plus 14. This is a graph that is going to have x-intercept of 4 and slope of 1/4. So here we have the graph here. Or another way, think of it as 4x minus 16. So we see the linear graph is going to always be to the right of the curve. And because of that, we can do right minus left. But before we do that, we can set up and find intersection. So set the two equations equal to each other, which is 1/4 y squared minus 1, set equal to 1/4 y plus 4. To make this a little bit easier, I'm going to multiply everything through by 4, so I can undo or just rid the equation of fractions. So if I distribute the 4 through everything, all the terms, I get y squared minus 4 equals y plus 16. Bring everything over to one side, y squared minus y minus 20. Factor, and we get y minus 5, y plus 4. We get y equals -4 and 5. And then we know the right curve is going to be, right graph will be the 1/4 y plus 4. The left is going to be the parabola, which is going to be 1/4 y squared minus 1. Combine like terms as much as we can, then we can go through antiderivative. In this case, find the antiderivative going through power rule. After you do that, then plug in upper and lower bound. 5 plugs in for all the terms. minus, then we plug in -4 for all the x values. Combine those terms, we get 243 over 3. All right, last one here, number 11. We have y equals negative sine of x and y equals 2 sine of x. So negative sine of x and 2 sine of x, we know that they're going to have the same period. The amplitude is just going to be a little larger here. But y equals 2 sine of x will follow the same pattern as y equals sine of x. So we'll just go, instead of from -1 to 1, it'll go from y value of -2 to 2. Y equals negative sine of x is just going to be a reflected version of y equals sine of x. So between -pi and 0, this essentially is going to be similar. The y equals 2 sine x will be similar to the pattern for y equals sine of x. We know y equals negative sine of x will be the reflected version of y equals sine of x. So here's y equals negative sine of x. We want to find the shaded region between -pi and 0. So in this region, the top curve will be the negative sine of x. The bottom will be the 2 sine of x. If I want to find the interval, or the boundaries, the intersections, I set the two equations equal to each other. 2 sine of x equals negative sine of x. Combine like terms, bring everything over to one side. Sine of x is equal to 3 sine of x equals 0, which is sine of x equals 0. So sine of 0 at 0, negative pi, pi, 2 pi. So intervals of pi. So from -pi to 0 is the boundary that we're concerned about. Top curve is negative sine of x. Bottom curve is 2 sine of x. So from -pi to 0, top minus bottom, combined terms, we get -3 sine of x. The integral for sine is going to be a negative cosine. So negative cosine and this -3 will cancel out to be positive. So 3 cosine of x is the antiderivative. Then we plug in the upper and lower bound. 0 gets plugged in first. Then we plug in the negative pi. So 3 cosine of 0. Cosine of 0 is just going to be 1. So 3 times 1 is 3. Cosine of negative pi is going to be -3. So negative times -3 is +3. So 3 plus 3 is equal to 6.